Hi, and welcome back to another part of our lesson on number systems. In this video, we will discuss binary numbers. In digital electronics, a binary is a number system that only uses two digits, and these are 1 and 0. Computers operate in binary, so this means that it can only understand 0 and 1. A single binary digit, also known as bit, can only represent false for 0 and true for 1. However, combining a series of zeros and ones can represent large numbers. We have different sizes in binary. The first one is bit. A bit is composed of one bit. It could be possibly 1 or 0. Second is nibble. Nibble is made up of 4 bits. The third one is byte, and one byte is made up of 8 bits. The fourth one is word. Word has 2 bytes, and this totals to 16 bits. The last one, the double word, or also known as long word. It has 4 bytes. It's better to have an idea about the sizes of binary because on our succeeding lesson, we are going to solve problems in binary numbers with different sizes. So let's move on. So we have here a table showing the decimal number and its equivalent binary. So 0 decimal is equivalent to 0 in binary. 1 is the same as with binary. However, for 2 down to 10, this differs from binary because 2 down to 10 is made up of combination of 1 and zeros. On the succeeding slides, we are going to figure out how these binary numbers can be represented in decimal form. So let's move on. So let's say we have these binary numbers 0110.101. Remember that binary numbers have a base number of 2. So let's rewrite this binary number with a bigger space between each bit. So let's start solving from the first bit. So we have to multiply each bit by 2. And we have to add an exponent starting from 0 going to the number of bits you have in your binary numbers. And then for the second bit, multiply this again with 2, but this time the exponent is 1. And for the third bit, it will be the same thing, but the exponent is 2. And for the last bit, the exponent is 3. So as you move to the left of your bits, you have to increment your exponent by 1, starting from 0 up to the last bit of your binary digit. Then after that, let's start working on the fractional part. So let's start with the first bit of our fractional part. So this will be multiplied with 2, but the exponent will start at -1. And then for the second bit, it will be -2. And then for the third bit, it will be -3. Now let's compute so that we'll be able to solve each bit. Let's start with this. So 0, because any number multiplied by 0, that is 0. So 2 raised to the power of 1, this is still becomes 2, and multiplied by 1, so the answer is 2. And for the next bit, this is 4. For the last bit, this is 0. Now let's work on the fractional part. Let's start with the first bit. So this becomes 1 times 1 over 2. And then on the second bit, this becomes 0. And then for the last bit, this becomes 1 times 1 over 2 raised to 3. So we are through with our whole number. So that is why we are just going to copy everything from the bottom. And now we will work on our fractional part. Let's start with the first bit. So 1 divided 2 times 1, this gives us 0.50. And we will just copy 0. and then this will give us 0.125. Now the last step is to add the whole number and the fractional part. So let's start adding these numbers. After adding these numbers, this will give us 6.625. So it means that this binary number is equivalent to 6.625 in decimal. Okay, so let's have another example. This time, let's try this binary number, 0101.011. So let's rewrite this with big space between each bit. And then let's start working on the first bit. So we will multiply the first bit with 2, the second bit with 2, and again, the exponent are increasing by 1. Now we will do the same thing for the fractional part. Let's start with 0, the second bit, and the last bit. Now the next step is to solve for each bit. Let's start with our first bit in the whole number part. So 2 raised to 0, this gives us 1, and 1 times 1, that is 1. And for the second bit, that is 0, and for the third bit, 2 raised to 2, that is 4, and 4 times 1, this gives us 4. And for the last bit, this is 0. Now let's start working on our fractional part. Let's begin with our first bit. So we have 0 there, so this is why the answer is 0. And then this becomes 1 times 1 over 4, and this becomes 1 times 1 over 8. Because 2 square is 4, that is why this is 1/4, and 2 cube is 8, that is why this is 1 over 8. For our whole number, we are through with computation, but for the fractional part, we're still going to simplify the 2 remaining bits. Okay, so let's just copy everything from the whole number, and then for the fractional part, let's solve the remaining bits. Let's start with the second bit. So 1 divided by 4 times 1, this gives us 0.25. And for the last bit, 1 over 8 times 1, this gives us 0.125. And the last step is to add the whole numbers as well as the fractional part. So this will give us the following form of number. And after adding these numbers, this will give us a total of 5.375. So this means that this binary is equivalent to 5.375. Okay, so let's continue. For our last example, let's try these binary numbers, 0111.11. Let's rewrite this in a wider form, but this time we will take a shortcut. What we will do is to count starting from the first bit of the whole number up to the last bit, and the same thing with the fractional part. So let's start counting with 1, and then multiply it with 2, so this gives us 2. And then multiply 2 with 2, this gives us 4, and then multiply 4 with 2, and then this gives us 8. And if you have plenty of bits at the left side, then you can just continue multiplying the number by 2. So if we have additional bits at the left side, so 8 multiplied by 2, this will give us 16, and 16 becomes 32, and 32 becomes 64, and so forth. So let's work on the fractional part. So we know that the first bit in the fractional part is 0.5, and for the second part, that is 0.25. Then after this, we will look on those bits that contains 1, and we will cancel those bits with zeros. Okay, so let's start with the first bit. So we have 1. That is why we are going to copy the number underneath it. For the second bit, again, this is 1. So it means that we have to copy the number 2. And then for the third bit, again, this is 1. So let's just copy 4. And then for the last bit, this is 0. So we have to cancel copying 8. We don't need to copy 8 because the bit is 0. That is why we need to write here 0 also. On the fractional part, let's start working on this side. And we all know that our fractional part contains 1. So it means that we have to copy everything from there. 0.50 and 0.25. Then after that, we will add each number. And after adding these numbers, it will give us this result. It means that 0.111.11 is equivalent to 7.75 in decimal. All right, so I hope that this video was able to give you a background about binary number system. So that's all, and see you on the next lectures.